everybody's half technical, kind of like advanced talk on Gossipsub. There's been a lot of interest in Gossipsub. There are around like 130 people signed up for this particular talk. I don't think everybody will fit in this room if they happen to show up. But yeah, we have very little time and a lot of ground to cover, so I'm going to get started. I'm Raúl. I'm the tech lead for the libp2p project from Protocol Labs. And this is what we're going to be talking about, demystifying Gossipsub. So Gossipsub is a scalable and extensible peer-to-peer gossip protocol. And our agenda for today is, first of all, I want to make sure that we all have kind of like a common baseline to talk about these technical concepts. So I'm going to do a very quick introduction to peer-to-peer PubSub. Who here is familiar with these concepts? Like maybe a 5 and above in a scale of 10. Fantastic. Okay, so I'm going to move through this pretty quickly. Then we're going to talk about what is Gossipsub. We're going to talk about how Gossipsub operates and what's up next. Because as you'll see, Gossipsub is a stepping stone in a roadmap that includes a lot more functionality that's coming in the future. So, oops. Oh my god, this is gonna suck a little bit. All right, so let's talk about what is PubSub. PubSub is a message-oriented communication pattern, right? This is in stark contrast with stream orientation. So here we're not interested with PubSub. We're normally interested in sending transactional messages and small units that are actually messages and not streams, right? Over the wire between a bunch of peers that are not necessarily talking to each other. So the interaction model of PubSub is end-to-end. This means that end peers are publishing messages about a particular subject, and a lot of other peers in the network are interested in consuming messages from that particular subject, right? This is, as I said, in contrast to RPC, or request-reply patterns, which are mostly one-to-one. Now, PubSub communication is asynchronous and decoupled in nature, right? This means that whenever I send a message as a producer, I have no guarantee, first of all, who is actually going to receive that message, because peers don't have a complete view of the network and a complete view of the subscription state, and it's also asynchronous because there is no time dependency. I received no explicit confirmation from any peer that they've actually received my message, right? Processes act as publishers and consumers of messages, and in a peer-to-peer network, this is important because a process can act as both things, and they congregate around topics of interest. Now, PubSub is widely popular in enterprise software. If you've heard of products and projects like Apache ActiveMQ or Kafka RabbitMQ, then that's it. But in those contexts, it's usually centralized around brokers in private networks, and it's definitely not. These approaches are not suitable for public message networks. So what is decentralized peer-to-peer PubSub? First of all, it's brokerless. It means that we have no central authorities to keep track of subscribers, publishers, topics. It's self-regulating. Whenever we deal with peer-to-peer networks, we have to model churn, right? And networks can rotate in presence very rapidly. So there is no global knowledge. There is no single peer that is an authority that has a complete view of the network. And the network behavior actually emerges from small, tiny, local decisions that peers are taking along the way, right? So peer-to-peer PubSub is usually constructed as an overlay network with peers collaborating to ensure message deliverability, right? And when we say overlay, there's usually an underlay, right? So it's an underlay network that actually makes sure that messages and traffic gets routed. And usually algorithms will assume that the underlay is well connected. So this means that I can always find a path from A to B, and if I can't, that's a pathology. So just to set a baseline for terminology, a topic is a subject around which peers congregate and they emit and receive messages. Subscription is the act of expressing interest on a particular topic. Publishing is the act of creating a message and pushing it out to the network. Forwarding is the act of propagating a message to other peers on the topic. And ambient discovery is something I'll talk about in a second. So the desirable properties in peer-to-peer PubSub are reliability, resilience, efficient dissemination, altruism-free routing. This means that only those peers that are actually participating in a particular topic will will actually contribute to forwarding that topic, and we're not burdening the rest of the peers on the network that are not invested in a particular topic and disseminating that. It has to be scalable across various axes. So we're talking about number of nodes, number of topics, messages, subscriptions, subscribers. All of these are different axes for scalability. There has to be a low overhead for maintenance. As I say, we are relying on peers making local decisions so that messages are globally routed in the network. And ideally, we want a protocol that is simple and easy to understand. So we'll see if we've actually managed to do this with Gossipsub. All right, so what is Gossipsub? The key elements of Gossipsub is that, first of all, it's a scalable and extensible PubSub protocol. So Gossipsub in itself is not necessarily intended to be a final usage of a peer-to-peer PubSub protocol. It is a protocol on top of which we can overlay different routers to take different decisions. And Gossipsub actually provides the primitives to make sure that, first of all, messages are delivered, and second, there's enough gossip metadata circulating on the network so that different and alternative decisions can be taken along the way. It was envisioned and specified initially by a developer called Viso. He's in the libp2p core team. And as I said, it provides a base layer and primitives to build adaptive, self-optimizing routing algorithms capable of repair and rearrangement in the network in the presence of churn and so on. So the key aspect of Gossipsub is that it combines stable reciprocal meshes with gossip about message flow metadata. We'll dig into this in a second. And it succeeds a protocol that we had in the libp2p stack, which is called Flotsub, and it's basically the dumbest protocol in terms of peer-to-peer PubSub. You disseminate a message to every peer that you're connected to, that you know is interested in the topic, right? Which is great because it's robust, it's resilient, and it can take minimal latency paths because you just push the message out, and it will, those peers that are closely connected to you and have a fast link with you will receive it first, but it also creates a lot of write amplification, and it basically clogs up the bandwidth because you're creating a lot of duplication in the network. As I said, Gossipsub is the stepping stone towards the grand mission of Episub, which is, I'll introduce it a bit later, but basically concocts ideas from Plumtree, Hyper-V, and Locust. Warning, the status of Gossipsub is currently alpha. Right? And this is very important for people to understand. It is a protocol that we're going to continue iterating on over and over again. And as I said, it's a stepping stone towards this more stable and feature-complete protocol called Episub. There are 3 implementations. There is the reference implementation in Go that the libp2p core team produced. There is a implementation by the Sigma Prime guys who are just here. Raise your hands, please. Get some credit. Fantastic. It's currently sitting in a fork, and I don't know if the ChainSafe guys are here. I don't think they are, but they also contributed, and they created a Gossipsub implementation in JS. Cool. So how does it work? I'm going to go through different layers of the protocol to kind of like do a walkthrough. So the first thing that you need to understand is that Gossipsub is actually a hybrid of 2 different networks, right? That are on the same protocol, that are on the same underlay. So there is a full message network formed by reciprocal links through which messages are forwarded. And this is, reciprocal is the word reciprocal is very important because this is supposed to be a stable mesh where peers are actually exchanging messages with one another. So if I'm peer A and I'm interacting with peer B in a topic, these 2 peers will actually be exchanging messages with one another consistently. And then there is a metadata-only network that carries gossips about what peers have actually seen. So as I said, the full message network, we call it mesh, is a sparsely connected network of reciprocal links between peers that are actively consuming and interested and therefore forwarding a particular topic. The construction of the mesh is actually randomized and is self-stabilizing because it has a number of stabilizing parameters, particularly the degree. So peers are configured, the mesh is configured with a target degree, which by default is 6. There is a high and low watermark, which by default is 4 and 12, and peers will strive to maintain the connectedness for a particular topic at an optimal level of 6, taking compensating action whenever it goes below the low water mark or above the high water mark. This is we keep that leeway to avoid drastic, downcutting and upregulating. This is so a stable mesh is complemented by a metadata-only network, which is a densely connected network that augments the mesh with gossip propagation about which messages are actually available. So this enables routing decisions to be made. If I have, so the easy way to put this is, in a particular topic, if I have 50 peers that are interested, that are consuming, so 15 neighbors of mine are interested in a particular topic, I'm only allowed to keep 6, right? In theory, based on the stable mesh. The remaining 9 will turn into gossip peers. So I will not exchange messages with them, but I will collaborate with them, telling them what messages I've seen without actually pushing messages to them. We'll go through this in a second. So how does topic membership work? As I said, a peer can be subscribed and be emitting messages on various topics at once. So peers can participate in many topics, either as subscribers, publishers, or both. And peers keep a view of all neighbor subscriptions, whether they overlap with ours or not. So if I'm subscribed to topic A and another peer is subscribed to topic C, but I'm not interested in C, I will still know that the other peer is subscribed to topic C. Okay? As subscribers, as I said, only engage in message propagation and gossip for pertinent topics. So I will only actually participate, and this is one of the key properties, if you remember, that are desirable in PubSub systems, in peer-to-peer PubSub systems, which is only those peers that are invested in a topic should be making effort towards disseminating that topic. So Gossipsub does satisfy that. So we have a concept that's called subscription beaconing, which is basically on every new connection, peers will exchange the topics that they subscribe to, and as the application that is using the libp2p stack joins or leaves topics, they will send updates to all other peers. So as I'm participating, as I become a participant in a new topic, I will send an update to all other peers. Now, we don't want to be very chatty, so we have introduced the concept of piggybacking. Right? So this means that we will try to coalesce updates, metadata updates to peers on top of messages that we anyway need to send them, right? Such as graphs and prunes and so on, as you see. And this kind of beaconing enables us to create inbound metadata flows and to do also ephemeral topic sending, which is also called fan out. I'll explain this in a second. So this, with regards to topic membership, there is 2 key concepts to understand here. There is the concept of grafting and pruning. I said that the stable mesh is actually a self-regulating mesh, and these 2 messages are key to regulate that mesh. So a graph control message proposes a 2-way full message stable link with a peer. So it basically, when a peer sends a graph to another peer, it's basically telling it, hey, I want to be part of your reciprocal mesh for this topic. Right? This means that I'm going to send you messages and you promise to send me messages as well. Right? Now the other peer can reject that because they're already beyond their target degree, right? And if they're rejected, they send back a proof. However, the other peer knows that I'm interested in that topic, right? Because I've beaconed a subscription to that topic. Therefore, even though I'm not part of the stable mesh, they will send me metadata, right? So this is where these 2 networks start making sense, right? Now, a prune control message dissolves a 2-way message, a 2-way stable mesh, stable link between 2 peers, and this could be sent in response to a graph that we want to reject, or if I'm down regulating my degree. Right? Now, another key aspect to understand is that by itself, Gossipsub right now does not include a mechanism for peer discovery. Right? So if we want to whenever we want to subscribe to a topic, we need to find a set of peers that are already subscribed to that topic. And this in the specification is called ambient peer discovery, right? We rely on a peer discovery mechanism which is present in the ambience, right? This is going to change as we go forward. There's currently a PR to add active peer discovery so that whenever the application subscribes to a topic, there will be PubSub will actually do a lookup of peers in that topic for them, for the application, and we also plan on introducing something that we call collaborative peer exchange. Now let's talk about message flow. When a peer wants to send a message as a message source, they just push the message to all stable to all peers in the mesh, in the full message network, right? Super simple. Now, peers that receive that message are actually message routers. So whenever they receive that message, they will forward that message to all other peers that are part of that mesh, of that view of the network, right? And we follow a heuristic to break cycles because we don't want to send the message back and forward, back and forward, back and forward, right? Now, we can also publish messages on topics that we don't subscribe to, right? And this is interesting for things like, for example, IPNS, the Interplanetary Naming Service, where we want to send updates from whatever a name, the mapping of a name changes to a different hash, for example, right? So you don't necessarily, the peer that's watching, for example, a DNS server, a DNS name server somewhere, and that's noticing this change, doesn't necessarily want to be subscribed to those topics, right? So there's the possibility of sending those messages, and when we do that, we basically remember that we keep in track of what peers are actually subscribed to the network. We're not forming stable meshes with them, but we keep in track of them. So if the local application tries to send that message, we will immediately form what we call a fan-out group from those peers that we know are already subscribed to that topic, right? And this is going to be an ephemeral option. So once we form that group, we push out the message, those peers we know are already part of the mesh, therefore they will forward that message internally, because the message has arrived inside the mesh for the topic. And after 2 minutes, we just dissolve it, because it was just an ephemeral set. So we don't want to keep it along for too long, because that would be aggregating state that we don't need. We also have the concept of topic validators and message signatures. So when an application sends a message, the application can configure, can attach predicates, validation predicates to topics, right? And ETH2.0, for example, is using this for validating signatures in blocks that are getting propagated and so on, right? And transactions. So when a message is published locally or before forwarding a message, this predicate will be called. If it succeeds, then the message will continue dissemination. Otherwise, it will just be dropped. We have the concept of asynchronous validators for heavier logic. And Gossipsub can also be configured to sign outbound messages and to strictly validate incoming signatures as well. Now, how do we regulate the mesh? There's a concept called heartbeat, which by default happens every second. This is a very popular concept in distributed systems. And this basically performs mesh and gossip maintenance functions, right? There's 3 things that happen. We regulate the mesh degree for every topic, we emit gossip, and we slide the message caches. So this is kind of like how degree regulation works. As I already explained it, if we're below a certain threshold, we will try to add peers to the mesh for that particular topic. If we're above a certain threshold, then we will prune peers from that topic to try to keep the degree at a stable constant. To be able to do this, we keep a bunch of local states, so topics that are subscribed to, topics that are recently sent a message to. This is the fan-out groups, peers that we currently connected to, and what kind of links we maintain with them, whether it's a full link, message data link, or if they're fan-out peers, and what messages were recently seen. Why is this important, this last bit? Because we send gossip. So this is where the gossip comes in. So for every single peer that we know is interested in a particular topic that is not part of our stable mesh, we will collaborate in the network by gossiping what messages we've seen in that particular topic. So we don't send a message to them, but what we do is with every tick and every heartbeat, we will with the message, we keep in a message cache, and we keep in kind of like a sliding window of the messages that we've seen in the last 30 seconds, 2 minutes. This is configurable. We will send them a list of all the IDs of the messages that we've seen, right? And this usually happens as well. We try to piggyback this because we don't want to create excess overhead in the network by sending this metadata around every time that we see a message. So we try to piggyback. If we have a message to send them anyway, then we try to piggyback these control messages on them. Now, if a peer spots a message that they haven't seen, right? They can ask for that message. They can pull that message by sending an I want control message. So in that I want control message, they will be listing the messages that they want us to push to them, right? Why is this important? This is important because it allows us to take routing decisions. So imagine the case where you have a stable mesh, right? You're in a topic, you have a bunch of peers that are sending you messages, and another peer, which is gossiping with you, tells you about a message that you haven't seen yet. This means that that deliverability towards you is not 100%, right? Because in your mesh, you haven't received that message yet, right? So you can use that as a sign, as a hint, to try to repair that pathology, right? By pruning peers that you believe are unhealthy and grafting with the peer that sent you the message who probably has a better route to the rest of the mesh than you do, right?
You have 1 minute left.
Okay, fantastic. I think I'm almost done. So yeah, this is kind of like a bit of a schematic view of what's on the wire. By the way, all of these images and so on, you can find them on the web, so don't worry. I'll just show you what they are. Now, I just want to talk quickly about what's next. For Gossipsub, first of all, we want to formalize Gossipsub into an academic paper. We want to harden the reference implementation in Go. We want to refactor the code base to enable pluggable routers. This is, for us, very, very important for the vision of Gossipsub itself. And formalizing Gossipsub into an academic paper is going to be also a robust step in allowing other downstream projects to actually build on top of that, analyze it, and to get all this work peer-reviewed, because it's essentially a new contribution to the state of the art. We want to integrate discovery mechanisms, and there are various benchmarking efforts underway. Important aspect is said, Gossipsub is not the final destination, right? Gossipsub is a step along the way. Really, the key aspect here is, and where we want to get to, is a protocol that we call Demystifying, which is a combination of Gumtree, HyperView for membership maintenance, and GoCast for the proximity awareness, meshing, and so on. And this will allow us essentially to model the kind of behavior that I described. So if with Demystifying, we'll be able to build dynamic dissemination trees that are mutating and that are adapting to the conditions of the network, by keeping track of the peers that are better connected to the network, and as well those peers that happen to present pathologies with us, right? So whenever we find messages that we haven't seen, that are incoming gossip from another peer, we can rebalance the tree and make sure that we always have a good connection to the network, right? We want to, so this is what we also call the self-healing mesh. We want to introduce adaptive cache windows and things like collaborative and passive membership views. So something that's key here is the ability to send advisories over the network of what peers are available in which topic. So ideally, you want to use an ambient discovery mechanism, like the DHT, for example, to find a seed, a limited number of peers that acts as a seed to bind to that topic. And once you have those few peers, which are probably overloaded because they are being advertised, right? You want to inquire them for other members that they know about in the mesh. And you want to create gossip, not just about the messages that are available, but about what peers are present in that topic, right? So this is something that's going to be cool. That's coming down the pike. It also has some notions of peer exchange. Cool. So as I said, all of these diagrams and these schematic views, which are pretty nice and pretty beautiful, they're available under the docs website. So make sure that you check out the new snazzy docs for Gossipsub, which we just released 1 week ago. Just in time for DevCon. And in time for me to do this.